All right, now we're going to investigate the derivatives of the inverse trig functions. Now, you just have to memorize these, all right? We're not going to prove them. We're not going to derive them. As long as you have a differentiable function u, the derivative with respect to x of the arc sine of u is u prime divided by the square root of 1 minus u squared. Now, let's look at the derivative with respect to x of arc cosine of u. It is minus u prime divided by the square root of 1 minus u squared. Do you see the similarities? Just like sines and cosines, the derivative of sine is positive and the derivative of cosine is negative. But in this case, it's actually the same function with the negative sign. Now, with arctangent, the derivative with respect to x of arctangent is the derivative of u divided by 1 plus u squared, while the derivative of the arc cotangent of u is minus u prime over 1 plus u squared. Now, the derivative with respect to x of arc secant u is u prime divided by the absolute value of u, and you have to use that unless you know your function is always positive. It's u prime divided by u, absolute value of u, the square root of u squared minus 1. And the derivative with respect to x of the arc cosecant of u is minus u prime divided by absolute value of u, square root of u squared minus 1. So there's a lot of similarities. I know it just seems like I'm just giving you so many formulas to memorize, but there are similarities. And let's start by just doing a couple. I want d dx of the inverse sine of 2x. In this case, u is 2x. So du dx is 2. So using my definition, the derivative of, I'm finding d dx of sine of u, inverse sine of u, is u prime divided by the square root of 1 minus u squared. So this becomes 2 divided by 1 minus 4x squared square root. The application is actually fairly straightforward. Now let's come over here and find the derivative with respect to x of the inverse tangent of 3x. So u is 3x, u prime is 3. So d dx inverse tangent of u, going back to your definition, it's u prime divided by 1 plus u squared. So this becomes 3 divided by 1 plus 9x squared. Straightforward, right? Easy peasy. You can do these. Okay, you knew I was going to get a little bit more complicated. What about d dx of inverse sine of the square root of x? All right, let's let u equal the square root of x. U prime is 1/2 divided by the square root of x. So I'm looking for d dx of the inverse sine of u. Going back to my definition, that is u prime divided by the square root of 1 minus u squared. See, after you write this about 15 times, you get to where you know it pretty well. So this is 1 divided by, let's see, 2 square root of x, and then that's going to be, that's u prime, and then it's 1 over the square root of 1 minus u squared. Let me rewrite that. This is 1, because I want all those 1s. 2. You don't have to do this. You can write it this way. Or we can combine. All right. In general, simplifying only when it makes sense or makes something easier. Now let's look at this one. The derivative with respect to x of the inverse secant of e to the 2x. So always let u equal the argument, because otherwise it's going to be an utter mess. And all right, so u prime is 2e to the 2x. So I want d dx of the inverse secant of u. And yes, I do want you to write all of these steps. This is u prime divided by the absolute value of u times the square root of u squared minus 1. Now, u is always positive, so I'm not going to really need my absolute values down here. U prime is 2 e to the 2x divided by u e to the 2x square root of u squared. So that's going to be e to the 2x squared is e to the 4x minus 1. Now, it does make sense to simplify this. So your answer is 2 divided by the square root of e to the 4x minus 1. Now, sometimes you're going to have messy derivatives. And let's just be honest, that's just what it is. Suppose I want to find this derivative right here. Y prime, okay, the derivative of the inverse sine of x is 1 over the square root of 1 minus x squared plus, now I need to find the derivative of this, so it's 1/2 times negative 2x times, divided by the square root of 1 minus x squared plus derivative of x is just 1, square root of 1 minus x squared. So we just use the product rule here. Okay, ugly. I never said it was going to be pretty. Matter of fact, I think I warned you it wasn't going to be very attractive. So let me do a little simplification. This is 1 over the square root of 1 minus x squared. Half here, this becomes minus x. Did I lose it? Yeah, I lost my x here because I forgot to carry my x over here. Guys, you can't let me do that. Okay, so that becomes negative. That's x squared divided by the square root of 1 minus x squared. And this is plus the square root of 1 minus x squared. When you do these, please take your time. I like to get in a rush, and you can see what happens when I do. All right, so let's get a common denominator here. This is 1 minus x squared divided by the square root of 1 minus x squared plus the square root of 1 minus x squared. All right, so this becomes what? The square root of 1 minus x squared plus the square root of 1 minus x squared. Oh my goodness, look at that. All right, folks, seriously, did you expect that to simplify so nicely? All right, you give it a go. Turn the tape, stop the tape, do these problems, turn it back on when you're done. All right, now we're going to analyze inverse trig functions. Okay, if I look at this right here and I want to analyze, I guess I want to analyze the graph, let's start by taking the first derivative. Okay, first derivative is going to be 2 inverse tangent of x, lower the power, 1, times the derivative of the inside. The derivative of inverse tangent is 1 over 1 plus x squared. So this is 2 times the inverse tangent of x divided by 1 plus x squared. Now, if I look at this, I can see my first critical number is when x equals 0. All right, because I need when my numerator equals 0. So that's my critical number. All right, so let me look at the second derivative. All right, this is 1 plus x squared. Now I have to use the quotient rule here. Times 2 over 1 plus x squared minus twice inverse tangent of x times the derivative of the denominator, which is 2x. Oh my gosh, divided by 1 plus x squared squared. Oh God, let me simplify this down a little bit. This is 2 times 1 minus, cross multiplying here, 2x inverse tangent of x, all right, divided by 1 plus x squared squared. Now, where is this 0? Of course, this is going to be 0 whenever the numerator is 0. So whenever 1 minus 2x inverse tangent of x equals 1. Now, this is not so easy. Let's just, if we put this in our calculator, we're going to find that this has zeros. I guess, when is that 0? Not 1. This has zeros when x is about plus and minus 0.765. All right. And so what do we have? Let's see. We know the limit as x goes to infinity of tangent x squared is pi squared over 4. All right. So we know we're going to have some horizontal asymptote here. We know at x equals 0, we're going to have a critical point. And using the first derivative test, we can see that that is a minimum. We see we have points of inflection at plus or minus 0.7, if that's 1, and negative 1. We're going to have points of inflection at about 0.7. And we can go through and find those values. And then we're going to have some sort of asymptote. Some sort of asymptote. And I'm not doing a very good job of this. It should be nice and smooth. See if you can give it a go. When you're done, restart. We have one more really cool thing to do. Now, sometimes we can use this to solve real problems. So suppose you're a photographer and you're taking a picture, and it's the picture is 4 foot. So that right there is 4 foot, and it is 1 foot. The camera lens is 1 foot below the outer edge, so this is 1 foot. How far should the camera be to maximize the angle subtended by the camera lens? Oh my gosh. So looking at this, we can see the total angle subtended there is, what, beta plus alpha. So I'm looking for beta, and that's theta minus alpha. Now I'm going to rewrite these in terms of the arc cotangents. So the arc cotangent, theta is the angle whose arc cotangent is x over 5. This is going to be minus alpha, whose is the angle whose arc cotangent is, oh, just x over 1. All right. All right. Now I'm going to do d beta dx. And this is minus 1/5 divided by 1 plus x squared over 25. And this is minus a negative 1 over 1 plus x squared. And if I do my algebra down, I get this is 4 times 5 minus x squared divided by 25 plus x squared divided by 1 plus x squared. And this is 0 when x is plus or minus the square root of 5. So we can use the first derivative test, and we find that this is indeed a maximum value. And so x, when we solve for x, is about 2.236. I'll just take it to the third. Now, these are all of your basic functions. Know them. Know these cold. You're going to have a quiz on basic differentiation rules. Now, try this problem. Slug through your algebra. When you're done, turn off the tape, finish homework, have a great evening.